So we're going to evaluate now the resultant force that is required to balance this system so that it can be in equilibrium. Now the system on the left hand side is a very simple setup where we have this load bearing 400 newtons, and one of the ties to the left, which is our 320 newtons, is carrying some load there, and then we have another tie to the right which is bearing 250 newtons. So it's quite easy to start this one off, and I'm going to start by establishing a scale. And for the scale, we could say that 1 centimeter is equivalent to, let's say, 10 newtons, for example. So now the first force I'm going to draw in is that 400 newtons. We could have started with any other one. I'm just going to use the 400 newtons, and if my scale is 1 centimeter to 10, then this should measure 40 newtons. So I'm just estimating here because the purpose of this is to demonstrate how to do it, but I'm just estimating here. So this here would be our 40 centimeters. And then now to draw the next force member, what I like to do is to use a reference line, which I'm going to show you what that looks like now. So at the tip of this arrow, this is representing my reference line, and this reference line, the only purpose of it is to measure the angle. So now the next force member that I'm going to draw in is T2, which is 250 newtons, and it's at an angle of 45 degrees. So what I would do now at the tip of this arrow is draw in that force and ensure that I measure as accurately as I possibly can, and it also needs to measure exactly the same, which is 45 degrees. So right here in the corner should measure 45 degrees, just like it is over here on the actual diagram. And then now in terms of the measurement, because I'm using 1 to 10, then this would measure 25 centimeters. So the next step, again, I like to use the method where I draw a reference line at the tip of the arrow, and I'm going to do that one more time. So this here is representing my reference line, and again, the only purpose of it is to measure my angle. So I am now going to draw in T1, which will measure 32 centimeters, and it should be tearing off to the left at an angle of 30 degrees. So let's get that done. So that's now my T1s going off to the left at an angle of 30 degrees. And I like to insert the angle as well, precisely where it's located on the diagram. So that's where the 30 degrees will be, right as it stands over here on the diagram itself. Now the final step is to draw in the line that connects, the line that closes this shape. And what that will look like now is just simply to connect the lines and close the shape like that. So now when you measure that line with your ruler, whatever it measures, this will be the value of your resultant. So that's representing your resultant, and the measurement will of course be converted into newtons. And in terms of the angle, what you have to do, draw a reference line like so, and the angle of this will be right here. So that's what you measure, and you notice that these arrows are going around, trailing each other like that. But as for this one, it's going back onto those other arrows, and that's where the angle forms. Now if you want to understand how to apply this method to analyze a truss system, then check this next video out to get more advanced using this method.